Okay, everybody, let's go over the solutions here to this ACT practice that you did. Let's just go through these one by one. So taking a look at number one, hopefully we understood the question. If we have 16 times 16 times 16, that's equal to 64 times 64 divided by what number? So you have your 5 choices there. They want you to pick what number n actually is. So what I would do is I'd just type them into a calculator and do 16 times 16 times 16, get 4,096. And then type in 64 times 64, you get 4,096 again. So what does n need to be if we have 4,096 divided by n to still keep it at 4,096? Yuppers, it's gotta be 1, gotta be 1. Alright, let's look at the next one. Alright, so this one's a pretty straightforward problem. The ACT is going to throw some fraction problems at you. A lot of times they like to ask you equivalent fractions like these. So if you have 30 over 48, that's equal to all those other fractions except for which one. So we did this recently, right? If we were to order numbers from least to greatest, it was a lot easier when everything was a decimal. So let's just go ahead and do that again here. Convert 30 over 48 into a decimal, which gives us 0.625. So then we just go through the rest of these here and figure out which one is 0.625. So if you look at this one here, 5 divided by 8, that's 0.625. 3 divided by 12, hey, wait a second, that's 0.25. Take a second to confirm the other ones. Divide. Oops. Bring that back. Divide. And where's that last one? Oh, we don't need to change that one. That's already 0.65, right? So there we go. We've just got our answer right there. It's got to be B. Alright, number 3. This was a tough one. So when we look at this one here, you have to first understand that if the average age is 42 out of 3 people, then if we were setting up an average situation here, we'd have something that kind of looks like this, right? We'd have an unknown age of all 3 of those guys combined, then we divide it by 3, we'd end up with that average age of 42, right? So what we could do here is we can actually figure out what x actually is here if we wanted to. That's be 126. How do I do that? Yeah, we had to multiply that 42 by 3, right? So then, if a 4th person joins in and the average now drops to 40, it'd have to look something like this. Take the original age of those 3 guys, add in an unknown value, y, and then divide it by 4, and then we'd end up at 40. So we can do the same move here and solve for x plus y, or what we could do is put the 126 in there already. But we'll do that right now. So if we multiply both sides by 4 to get that fraction out of the mix, now that's 160, and then we can drop that 126 in there. 126 plus y equals 160. So doing a little bit of subtraction there, 160. Let's write this in here. My board went asleep. Okay. So if we take the 160 and we subtract the 126, that gives us our final answer there of 34. There we go. Let's look at the next one. So now the trick on this one is remembering from your geometry days that when you have 3 angles in a triangle, they have to all add up to 180 degrees. So that's where we have to start. So 5x plus 4x plus x needs to be equal to 180. So notice we have 3 like terms there, so go ahead and combine those together. So 10x equals 180. To solve for x, we just divide both sides by 10. And then we can plug that in. So there we have it, we got 72. And so that's our answer. Kind of trap answer there would be the 18 there, just because they were asking for x, or they asked for 4x. Okay, so number 5, the correct answer here for number 5 is C, 1 and 2 only. Now how can we do that? There's a strategy that I will definitely mention quite a bit when we're getting ready for that ACT, and it's a strategy called substituting numbers. Notice in the start of the problem up here, they gave us a couple of scenarios here. First, they told us that x needed to be greater than y, and then another number z, which had to be less than 0. So when this happens, just come up with numbers that make this statement true. So what I could do here with these ones is, why don't I just come up with a number that's bigger than another number? In other words, let's make x 5 and make y 4. And then when you have a number like z that needs to be less than 0, it just means it needs to be a negative number. So let's just go ahead and make z a negative 1. So then what you can do is you can just start plugging in those choices and figuring out situations where that works. So me looking at this problem, if I look at situation number 1, now I have 5 times negative 1, and checking to see if that's actually less than 4 times negative 1. And I think it is. If you think about that number line up there, on the top of my wall there, we have negative 5 being less than negative 4, and that is true. So 1's true. If we look at situation number 2, of having 5 plus negative 1, and then, let's make this a little thinner, it's kind of chunky there, greater than, let's see here, y, which is 4, plus a negative 1, simplifying that, now we just have 4 being greater than 3. Hey, that's true also, so 2 works. But notice that if we look at situation number 3, we're going to be in some trouble here. So if we have, say, 5 minus a negative 1, and trying to check to see if that's less than 4 minus a negative 1, then if we're actually adding that, so we have, oops, not 5, we have 6 being less than 4 plus 1, which is 5. That's not true, so it does not work there. So it works for 1 and 2 only. Alright, so if we look at the next one, number 6. This is another situation where a nice ACT strategy is just going to be plugging in the answers. That's a little bit different than up here substituting your own numbers. Here, now we can just plug in the answer choices until we get a statement that's true. What I'm talking about here is, like at choice A, x is 4 and y is 4. If we put a 4 in there and a 4 there, we're going to have 4 plus 3 times 4, which is 12. Is that going to be equal to 13? No way. So then we just move on to another one. And if we look at negative 2, 3, try that one. I believe the one that's going to work, it won't work until we get here. We plug in the negative 5. We add 6 times 3, which is 18. Negative 5 plus 18, boom, 13. So that's how we end up with those answers. And we'll practice that strategy in the future. Number 7. Ooh boy, an absolute value problem, right? So the key thing to remember with an absolute value problem is that there's always 2 cases. Let's look at what those 2 cases were. The first case is x plus 3 needs to be greater than 5. The other case is that x plus 3 needs to be less than negative 5. So we have to solve both those 2 problems. So on one hand, if we subtract 3 from both sides, there's x being greater than 2. On the other hand, x could also be less than negative 8. And here's the problem. It seems awfully inviting to pick A, but actually A is a situation, if I draw a number line here, where if you have negative 8 and you have 2, x is in between those 2. The situation that we have here is actually a situation where here's 2, here's negative 8, and actually we are going outside. We're going out that way and we're going out that way. In other words, no middle. So it's actually not that situation there. And notice these ones, this isn't saying enough. There's more to it. And there's the other stuff right there. So since none of them say both, that means the correct answer here actually is none of those. Since none of those choices actually were saying the whole story. So none of those answers are true. Number 8. ACT will like to do this to you, and what they'll do is they like to throw in a really funky looking symbol, and they'll define what that symbol actually means, which, in other words, x and then an at symbol, y just means square x and subtract y squared. So when they give you this situation here, what that's really telling us is 3 squared minus a negative 2 squared. We have to square them first. Now we have 9 minus negative 2 squared, that's 4. 9 minus 4 is 5. Next. Yeah, not much we can do here, ladies and gentlemen, at least not at this point. But we could use a substituting numbers move here. If a divided by b is c, then why don't we just make a statement like 6 divided by 3 is 2. So now notice that a was 6, B was 3, and C was 2. So now they're asking us what the log of C is. In other words, what we can type into our calculator now is let's figure out what the log of 2 is. And notice if we take the log of 2, we end up with this decimal right here. So now that we have A being 6 and B equals 3, now we can go through and try each one of these choices here using those numbers in our calculator, and what we're looking for is when the decimals match. Notice that when I did my first move right there, the log of 6 minus the log of 3, we end up with that exact same decimal. Success. Alright, numero 10. This is a pretty complex problem, but one thing that we do know is that the area of the triangle in there is 40. And if we remember our area formula for a triangle, which is 1/2 base times height, we got to find the base and find the height. Now when we're dealing with the triangle here, where they also said that this was perpendicular right here, we just got ourselves a right triangle, correct? So with this right triangle, notice that both this length, let's see here, this length right here, and this length right here, they have to be exactly the same. So let's just call them x. So if we have a base and a height, they're both x, then really we're looking at x times x times a half, or in other words, a half of x squared. So what number do we need to take half of and end up there at the x squared? Well, we can do that with an 80, and then we can take the square root of that. So once we end up there, now we can finally figure out what the area of that circle is, remembering our good old area formula. Oops, I don't want that. There we go. Which is pi r squared. We can drop in now our square root of 80, square the square root of 80. We end up with 80 pi. Yeah, that was a tough one. These geometry ones usually are not too friendly to students. So when I see you guys and we start doing this a little bit later on in the year, we'll definitely get a lot of practice with these geometry ones. That's a tough one. Okay, here's another situation where if we're pretty savvy with the calculator, we can kind of wiggle our way out of this. Looking at this one here, we just need to figure out what p squared is. And all they told us that 1 over p is the square root of 0.25. Well, what I would probably do with this problem is rewrite that 0.25 right as 1/4. And I think we just did this with square roots, right? You have a square root of two things, top and the bottom. You can square root the top and you can square root the bottom. So the square root of 1 is 1, and the square root of 4 would be 2. So we'd end up right here. So now notice if we have an equivalent statement here and the 1's match the 1's, then shouldn't p be 2? And if p is 2, p squared's got to be 4. Booyah. Alright, almost there. Alright, number 12 is another tricky problem to navigate through, but once again I believe we can probably pick and choose some numbers here that work. So b just needs to be an odd integer greater than 1, so if you picked say a 3 or a 9, let's just start working with that. I'm going to pick 9. So if we did that and used a value like say 9 and started working that with other problems, me just messing around with this, trying to figure out which ones are going to give me odd numbers when I'm done with it. So if I try 9 cubed minus 1, I get 128. That's not odd. If I do 9 cubed minus 9 squared, I get 648. Not odd. 1 plus 9 cubed, certainly not odd again. Keep on going here. 9 plus 9 squared, not odd. So notice the last but not least, there we go, we end up getting an odd number there, so E needs to be the correct answer. Let's mark that up. Alright, let's wrap this puppy up here. This one here was another doozy of a problem. You know, I could go into the specifics of all this, which would involve us factoring out that 3, leaving us with this here, and then we can cut that number in half and square it. Bottom line, folks, there are going to be some problems on the ACT that are just brain melters. One thing that I will say about this ACT today, and I'll say it again to you many, many times, this test is 60 minutes, 60 questions, 1 minute per problem. I will say this, the ACT test writers do not expect you to finish this test. They don't. They expect most the average student won't finish this test. So the point I want to make here is that there is no problem. None of those 60 questions are worth more than 2 minutes of your time. You don't have enough time to spend on those problems, and every single problem is worth 1 point. So move on to another problem that you could possibly have some more success with.